one. Yeah, just keep going and you'll see. Like, is this your last page? This one? Yeah, it's that one. You know what? Let's start with this one on the last page. So this one says, from the delta plot, the polar coordinate 6, 11 pi over 6. So remember that the 6 stands for R, and the 11 pi over 6 is your theta. So go to 11 pi over 6 first. So here's 11 pi over 6. And then you're going to go to R equals 6. So you're going to count 6. So this is R equals 1, 2, 3, 4, 5, 6. So there it is. I just counted the rings. So that's R equals 6. And that's angle equals 11 pi over 6. So that's equivalent to 6, 11 pi over 6. And that's it. And you remember that, right? And if for some reason they were to tell you negative 6, 11 pi over 6, then you would go in reverse. And it would be 1, 2, 3, 4, 5, 6. So it would be this one. But they didn't. But if they would have, negative 6, 11 pi over 6, you would have gone there like that. Because R can be negative in this one. All right, and then let's go to this page. So scroll until you get to example 2. Got it? All right, so in example 2, this says R equals 2. It doesn't have any theta, so theta is actually off, like 0 to 2 pi. So if it just says R equals 2, that just means this. Because it doesn't matter. You're sweeping for all values. R is like saying your radius is 2. And remember, you always measure your radius from the center. So this is 2 at all times. That makes sense? Same thing with this one. You see how it says negative 2? It doesn't matter. If it's just a number, like an integer, you still start from the center. And then, so that okay, you know what? Let's pretend we said something like negative 2 comma pi over 2. So what I would have done, if it would have been this, you would have gone a pi over 2, and then you would have gone negative 2, so you got to go backwards. So this would have been negative 2 comma pi over 2, see? Going backwards. So if you do that for all angles at R equals negative 2, you're going to get a circle again. Does that make sense or no? You can say no. Yeah. It's like negative, or the pi over 2 is always like at the top of the circle. Correct. Go down to like the opposite of it. Yeah, because it says negative 2. So I would have just gone backwards 2 units. So, and if I keep doing that for all angles, I would still form that circle. Does that make sense? Yeah. Notice that this one says pi over 6. It does not have any R. So R can be any value you want. So you're just going to go to pi over 6 and go forever. This is how it looks if R is positive. How will it look if R is negative? It goes into quadrant 3. Does that make sense? Okay. Sorry for the hiccups. I just drank a Dr. Pepper. Okay. So on this one it says, use polar rectangular conversion formulas to show that the polar graph R equals 4 sine theta is a circle. So I don't know if you were here or not, but when we did equation of a circle, an equation of a circle must look like this. X minus h close it squared plus y minus k close it squared equals r squared. And that's what I want it to look like. So I have this, and I have r equals 4 sine theta. The only relationships I know right now is this. So I'm going to go to the side note. So I know that x squared plus y squared equals r squared. And I know, let's see, what else do we know? We know that x equals r cosine theta. And we know that y equals r sine theta. And we know that our angle theta is equal to arctan of y over x. But you got to look at what quadrant you're at, right? If you're in quadrant 1, this will give you the answer. But if you're in quadrant 3, this will not give you the answer. So you just got to make sure you know what you're doing there. Okay, so here's what you ask yourself. Ready, Penna? What you ask yourself is, how am I going to make this look like this? Notice there's a letter or there's a variable that both equations have in common. What variable or letter is that? You're looking for a letter that both the top equation and this equation have in common. The radius. Good job. This one has an R. That one has an R. See that? So what I'm going to do, because that's the only letter they have in common, I want to get that R to be an R squared, to be like that. So I'm going to multiply this by R. Whatever you do to the left, you do to the right. Does that make sense? So then here's what we're going to have. We're going to have R squared equals, and then when I multiply that R by this, you're going to get 4R sine theta. Still okay? Yeah, ask me questions.
No, I get it. Can you just understand?
Then when I do that, I'm going to substitute. See how R squared equals X squared plus Y squared? That's what I'm going to plug in for the left. And I want you to notice that R sine theta is equal to Y. So that's what I'm going to put in for the right. So here's what I'm going to rewrite. I'm going to write X squared plus Y squared equals 4Y. You are done. So now all you got to do is make it look like that expression. So I'm going to move the 4Y to the left. X squared plus Y squared minus 4Y. I'm going to move that to the left. Plus blank equals 0, because there's nothing on the right. I'm going to turn that trinomial into a binomial. I take the middle number, I divide by 2. What's 4 divided by 2? 2. And then I'm going to square that number. What's 2 squared? 4. Whatever you do to one side, you do to the other. From there, I have X squared plus parenthesis Y minus 2, close it squared, equals 4. How do I get that? Why does it work? I know, Penna, don't worry. It's because this, look, Y minus 2 times, that's what it means. And when I distribute Y times Y squared, Y times negative 2, negative 2Y, negative 2 times Y, another negative 2Y, negative 2 times negative 2 plus 4. Look at that. So that is Y squared minus 4Y plus 4, which is what I was trying to get rid of. Not get rid of it, but I wanted to get a binomial with a square on it. That's what it means to complete the square. See? So I turn that trinomial into something that I can put a square. So now I have the center, because now look, it looks like this. HK is my center. So the center of this circle is 0, 2. And the radius is the square root of 4, because remember, that's R squared. So what's the square root of 4? There it is. So it in fact is a circle centered at 0, 2 with a radius of 2. So how does it look like if I were to graph this? It would look like this. Cool, right? Now, if you have a calculator, which you do, you have one right there, you could graph this really quickly to see that it's a circle. Watch. I don't remember if I have it already in the mode. Okay, let me show you. Okay, let me clear this. Let me reset it. Okay, so here's how what you do. You click on mode, and then you go to this, and you see where it says polar. I click on that, and I push enter. It might already be on polar because they were using it earlier today. So then when you click on Y equals, did it say R equals? Oh, just push enter on polar, and then go second quit. So how do you do that? You push the blue button or the second, and then quit, the mode button. And then click on Y equals. Does it say R equals? Okay, if there's something in there, clear it, and then just type this equation, 4 sine theta. So how do you type that? 4 sine, and then push this button here. And now check it out. When you push graph, I know it doesn't look like a circle, but we can make it look like a circle. Look, push window, and then, no, not window, zoom, and then it's the number 5. Square the window. And now look, it looks like a circle. See? We can zoom in on it. 0 to 2 pi, that's fine. X-Men 0 to 5. 0 to 5. Oops, I meant negative 5. Negative 5. Alright, graph. And let me make it look like a circle. Square the window. There it is. Cool, right? Okay. Alright, let's go to the next one. These you should know how to do already, but just in case you don't remember, we'll do one for you. Let's look at letter D. So it says, I want you to convert this to a rectangular coordinate. So first, how does it look in polar form? It looks like this. So pi over 4 would have been right here. But because I'm going negative, that would have been pi over 4. But I'm going negative. So you got to go in reverse. And there it is. That coordinate is negative square root of 2, comma pi over 4. See? If R would have been positive, you would have, remember, you always started from the origin. If R would have been positive, I would have gone that way, and I would have been in quadrant 1, and I would have been here. You know what I mean? Ask me.
I get it with like the pi over 4, but with the negative square, like 2.
All that means is go backwards. So if I have something like, I'm just making this up. So if I have something like 3 comma pi over 6, that means you go to pi over 6, and then from the origin, you stretch out 3. So you go, and I say that's a stretch out of 3, and that's 3 comma pi over 6. That's if I had it like that. But if I have a negative, so if I go negative 3 comma pi over 6, you do the same thing. That is still pi over 6 right here, but then you go backwards. So here it is. I'm going to go the same distance, but backwards. So that's negative 3. See? So it's still pi over 6, but then I went backwards to negative 3. So this coordinate here would be negative 3 comma pi over 6. Does that make sense?
And you just did the same thing with you.
Yes. Yep. I went square root of 2 to the back. And then, I don't want you to be a robot, but you could. All you got to do is go, if I want the x coordinate, you just do r cosine theta, and it'll always give you the answer. If I want the y coordinate, like xy, I go r sine theta, and it will always give me the answer. So watch. In quadrant 3, both x and y need to be negative. So x equals negative square root of 2 cosine of pi over 4. So what's that? Negative square root of 2, and then cosine of pi over 4 is square root of 2 over 2. Negative square root of 2 times square root of 2, that's square root of 2. That's 2. Square root times square root, the square root goes away. And I'm dividing by 2, so that's negative 1. Do you see how I did that?
Yeah.
Same thing for the y value. Y equals negative square root of 2 sine of pi over 4. At pi over 4, x and y have the same magnitude. See? And then you just multiply them. So you're going to get the same thing. So this coordinate right here is negative 1, negative 1. Cool or not cool? And that's what you're doing for all of these. That's what you did on delta as well, when you took delta. And, oh, what's up? Sorry.
Do you have a scientific calculator I can borrow for this semester?
I do. It's in my cubby.
At your house?
No, in the teacher's lounge.
Oh, in your cubby?
Uh-huh.
Cool. Appreciate you.
Uh-huh. No problem.
Why do you have it in your cubby?
Oh, because I don't remember. Someone threw it in there, and I just never took it out. Okay, ready for another one? So these, they give it to you in rectangular, and they want you to give it to them in polar. So I'm going to do letter B. So how does letter B look like? It looks like this. It's in quadrant 4. 1 comma negative square root of 3. So I'm somewhere down there like this. See? Here's the R. And it actually wants two values. So here's the R. So I'm going to do Pythagorean theorem. Do you see it? That's a 1. That's a negative square root of 3. Here's my right triangle. So that R is like the hypotenuse. So I'm going to go 1 squared plus negative square root of 3 squared equals R squared. 1 plus, when I square the square root of 3, I'm going to get 3. And then 3 plus 1 is 4. And then square root both sides, and you're going to get 2. So R is 2. It's cool or not cool? Okay, now I want the angle. I guess I could, if I wanted, get that angle there. Let's see. So if I want that angle, so I want arctan. Oh, hold on. This is Travis. I did have Mara Flores. She took off with Ramirez. I think she went to Winters. Okay, if she's not there, hit me up and I'll find her. Okay. I think she went to Wins, right? Okay, well, we'll find out right now. Y over x, negative square root of 3. So arctan of negative square root of 3 over 1. So this is a special number. It does happen on the unit circle. The unit circle doesn't go away. So on the unit circle, this happens here and here. So I don't, obviously the way this looks is quadrant 4. That's the one I want. I want to know where my x value is a half and my y value is a negative square root of 3 over 2. Why does it work there? Because negative square root of 3 over 2 divided by a half, the 2's cancel out, and you get negative square root of 3. See? And if you remember, do you remember what radian that is? The bottom is 3. Do you remember what the top is? That's a 5 pi over 3. You're pi over 3 away from a 2 pi. So I guess that's negative pi over 3. But pi over 3 is a reference angle. So you could say that one coordinate is, let's see, one polar coordinate is, my radius is 2. And you could say a negative pi over 3. Or you could say 2, comma, and you could say 5 pi over 3. Or you could say, let's say you want the R to be negative. Then you could also, so I'm going to give you 3. You could say negative 2, comma, 2 pi over 3. See? You could have gone to 2 pi over 3 up here and then go back, negative 2. So all 3 of these are different polar sets, a set of different polar, so it's 3 different sets of the same polar coordinate. Cool or not cool? All 3 of those are the same coordinate. Okay, so now let's go to the good stuff. You okay? Okay, don't worry, miss. These are the same ones that you have on that handout. I didn't switch any. You can just pretty much copy paste, but try to not look at this when you're doing it, so you can get some toughness. Okay, so you have this expression, and they want you to find the equivalent Cartesian equation, and then identify the graph if you can. So here's all you know. You know that x squared plus y squared equals r squared. You know that x equals r cosine theta, y equals r sine theta, and theta equals arctan of y over x. So then you look at this and you say, well, besides r, when I guess you could multiply by r both sides, but you're going to make things more complicated. This guy looks like this. So you have r equals 4 over sine theta. So what you want to do is you want to get it to look in terms of sine and cosine. And then as soon as, so then the logic behind that is because you have a sine there and a cosine there. And then what I'm going to do is I'm going to multiply both sides by sine to get rid of the sine in the bottom. So when you do that, so I'm going to go times sine theta times sine theta. When you do that, you're going to have r sine theta equals 4. And I know that r sine theta is a y. So this is that. So when I graph this, you're just going to have a linear line at 4. And that's it. And if you were to graph 4 cosecant theta on your calculator, you would get that line. So look, y equals, clear it, cosecant's the reciprocal of sine, so I'm just going to go 4 divided by sine theta. Hey, Miss Straight, where are you going? Our room, okay. And then I push graph, and there it is. See, it's this line up there. All right, so let's go to the next one. So on the next one, you see r cosine plus r sine equals 1. And then I'm thinking, okay, what is r cosine? Well, r cosine is x. Plus, and then what is r sine? R sine is y. See? Move the x to the other side. Y equals negative x plus 1. So this looks like positive 1. It's just a linear line with a slope of negative 1. Cool? Okay, next one. What I'm going to do, you see a sine and cosine, so you want to go ahead and multiply by sine theta minus 2 cosine theta. Whatever you do to one side, do to the other. Sine theta minus 2 cosine theta. And then I'm going to distribute. So here's what you're going to have. You're going to have r sine theta minus 2r cosine theta equals 5. So this is y minus 2x. That's an x. This is a y. Equals 5. Move the 2x to the other side. Y equals 2x plus 5. And there it is. That's what you're going to graph. It's 5, slope of 2. Okay. Come on, miss. Catch it next time. Okay, cosine squared equals sine squared. So again, we just have x equals r cosine theta and y equals r sine theta. Cosine theta is done by doing x over r equals cosine theta. And the same thing for the y. Y is done by y over r equals sine theta. So I'm just going to substitute. Remember that means this, cosine squared equals sine squared. So cosine theta is equal to x over r. So now I'm going to square both sides. And I'm going to have x squared over r squared equals laws of exponents. Notice I have an r squared on both, in the bottom of both. So that means that x squared must equal y squared. I can rewrite it as y squared equals x squared. And I'm just going to square root it. So that means y equals plus minus x. So that looks like an x going through the origin. You guys okay over there, guys? Okay. Okay, here we go. R equals 8 sine theta. So times R because I don't have an r sine theta to replace with a y. So When we do that, you're going to have now r squared equals 8r sine theta. Remember that r squared is this guy. So I come back and I go x squared plus y squared equals 8y. I'm going to complete the square again. So move the 8y to the left. So I'm going to write x squared plus y squared minus 8y plus blank equals 0. Now I'm going to complete the square. 8 divided by 2 is 4. And what's 4 squared? Yeah, 16. So I put plus 16. Whatever I do to one side, I do to the other. So now I have this. X squared plus parenthesis. This reduces to y minus 4. Close it with a square on it. Equals 16. So it's definitely a circle. It looks like a circle. So it's a circle. And the center is at 0, 4. And the radius is 4. So if I were to try to graph it, it would look something like that. Oh, I don't have, it just says x squared. It doesn't say I guess you could also written it like this. X minus 0 close it squared plus y minus 4 close it squared equals 16. So that number is 0, so 0 comma 4. See? Cool or not cool? And there it is, we did it all. So now you should be able to take care of that handout, right? Okay. So let's take care of that handout, miss.